Okay, this is your first video for Algebra 2, whether it's pre-AP or regular. On the front of your composition book, I would like you to write your name if you haven't already, as well as Algebra 2 and whether this is pre-AP or regular, and the class period. I didn't put that on mine because mine is for all of you guys. Um, until I can get my Elmo working, I'm going to go ahead and just do snapshots and annotations verbally. So if I'm going too fast, please let me know and I can stop it while you're watching this, okay? So on the first page, you're going to go ahead and do your table of contents. This is on the first page, right? Table of contents and the first topic. So our first topic for numeral 1 is domain and range with the subtopic of relations and functions so that we can understand where this is coming from. Go ahead and do this in color if you so choose. Remember, this is not mandatory. This is just optional if you'd like to be a little bit more organized and color-coded. So mine is in purple, relations and functions, with the number 1. Skip one page after this. So, sorry about that. So you have a total of 2 pages of table of contents, and go ahead and put this title on your third page. So our third page should have relations and functions and then the number 1. Again, if you choose to do this in color, make sure it's the same color that we titled relations and functions. The first thing you're going to write is a definition, and this is something very generic, very basic. Most of you probably already know this. You might have forgotten, but it's not too difficult. It says a function is a relation that has exactly one output for every input. In other words, one y value for every x value. Some of you might understand it better with this thing on the bottom. Your x values do not repeat, and graphically this means that your graph must pass the vertical line test. Okay? I'll do a couple of examples with the vertical line test. That's the one that people seem to forget. Go ahead and copy this. This is just definition stuff, very basic stuff. First example, is this a function? So I'm giving you a relation, 3 ordered pairs, okay, and you need to tell me whether or not this is a function. The easiest way to do this is to look at our x values. So we have 3 and 2 and 5 and see if they repeat or not. If they do repeat, it is not a function. If they do not, it is a function. So as we can see here, 3, 2, and 5 are all different from each other. And so therefore, yes, this is a function because the x's do not repeat. Okay. As an added bonus, I went ahead and threw in a little review moment, see who can remember what this means. Domain and range. Who remembers what domain is? Okay, hopefully you answered x values, which means our range must be the y values. So this is an easy one because we're given literally the points. So our domain for this one is just all the x's, which is the first number, 3, 2, and 5. And our range is going to be the second number, 4, 7, and 8. And we write these in list mode, which means we just put them inside little curly braces like this. Okay? Very easy. Algebra 1 material. Hopefully you remember some of this. Again, if you don't, you can ask me questions. You can always come back and watch this video later as a reminder. Okay? Another example. This is a graph example. This one I actually drew it right underneath that first example. And right next to this one, you're going to do another one. So you kind of have a problem up here, and then problem here, and problem here. Okay? This is asking whether or not this graph is a function, y equals 3. So for us to remember what y equals 3 looks like, go to your y-axis, which is this vertical one. Go to y equals 3, so here's 0. So 0, 1, 2, 3, and y equals 3 is actually all of this line across. Horizontal line, y equals 3. Kind of sounds opposite of what it should look like, but this line will always be y equals 3 because if I come over here, y is still 3. If I come over here, y is still 3. And the same on the other side. So it looks like this. When you're given a graph, this is when you use your vertical line test. The vertical line test is a test where you draw vertical lines through your graph. If that vertical line ever goes through more than one point, it is not a function. So if I were to put a line, let's say, like right here somewhere, okay? If it keeps going forever this way, well, it already passed through my graph right here. So it's only going to go through one point. And if you see all these lines that I drew, it only goes through that one point there. So this one does pass. So yes, this is a function. It passes the vertical line test. Okay. Another example, x equals 5. This is the opposite of the other one. So now I'm going to go to my x-axis and go to x equals 5. So 0, 1, 2, 3, 4, 5. And this one's going to be a vertical line because on this vertical line, x is always going to equal to 5. And again, stop me if I'm going too fast. This is as easy as pressing pause and play. So there it is, my vertical line. And just with the fact that it's a vertical line, that should tell you everything here. Does this pass the vertical line test? Is there a vertical line going through any 2 points? Well, no, this is literally a vertical line, so therefore it doesn't pass the test. So no, this is not a function. If you have questions on this one, please ask. I will probably pause right here. Okay, we have one more little topic to cover for today. And on my notebook, I actually ran out of room, so I went ahead and went to the next page. If you are also in the same position, you can title it again, Relations and Functions, and just put the number 1. That way I know that this is the same topic. Okay, so in this problem, it says find the output for each given input given f of x equals 3x plus 1 and g of x equals x squared minus 1. This is just a simple evaluate problem where you plug in an x value and find the y value that goes with it. Okay, so I'm going to show you step by step on this one. The first problem is f of 1 equals blank. So since it's f, I'm going to look at this problem here, f of x. I'm going to ignore g of x because all I want is the f. And I'm going to plug in 1 wherever I see an x. So if you had me last year, I always used to tell you, put a parentheses. Always put a parentheses. That way, in case it's negative and you have to square it, there's no miscalculations. So it looks something like this. So if you notice, I have my 3. Instead of the x, I have a parentheses, and there's a 1 inside it because that's the one that I want to evaluate. And there's my plus 1. At this point, it's a simple matter of actually calculating it. It's a little bit of arithmetic. 3 times 1 plus 1. So step by step, 3 times 1 is 3. Bring down that plus 1. And then 3 plus 1 is just 4. Yay, there we go. Okay, so again, find the function you're supposed to plug it into. Just match the letters. Take the number and plug it into wherever you have an x. In this case, 3x plus 1. 3 times 1, 3 plus 1 is 4. And I know some of these you can do in your head. That's fine. But I do want to see a little bit of work. Okay, if you can at least show me this step right here, you can jump down to that one. All right. One more example, g of 4 equals, so this time because there's a g in the front, we're going to use the g of x function. Just like before, where I had that x, I'm going to put a 4. So instead of x squared minus 1, now I have 4 squared minus 1. Again, make sure you put that parentheses because negatives do make a difference sometimes in specific problems. So 4 squared just means 4 times 4, which is 16. So I have 16, bring down the minus 1, simple subtraction. So the answer is 15. Okay, that is the last example. If you did not understand any of the concepts, please don't be afraid to ask questions. You can always go back and watch the video again if it went a little too fast for you or if I didn't pause enough. It's there to help you. So go ahead and get started, and I hope you understood.